All right. Okay. Hi everyone. I know that there is a deadline tomorrow, but that's life. Happy February though. So we got through 1 month. There's 2 more left. We can do it. So okay. All right. So that's pretty right. Hold on. Wait, that's worse. All right. Okay. All right. So I want to. So we're gonna do some easy stuff and then some not so easy stuff today. We'll start with the easy stuff, so just kind of telling you about realloc and stuff. And then once we have this, we'll actually try to implement strings the way they're implemented in Python. But first, we need to kind of talk about the downsides of how strings are implemented in C. And for that, we need realloc. So realloc is basically a way to resize a block of memory. So note, it's a block of memory, not an array. Cannot do it with an array, cannot assign to an array. But with a block of memory that's allocated with malloc, you can say, well, it used to be 100 cars, and then now I want 200, and you can do it like this. So this basically says, here is str, and just find me space in the memory table where I can store str contiguously now that it needs to have 200 characters. So realloc returns a value. It could be the same value. It could say, actually, you can use the 100 bytes that come after the current str. It's fine. Or realloc could say, there is no way that your current str can actually keep its space in the memory table because there is stuff after it that you cannot just relocate arbitrarily. So what it'll do is it'll find another space in the memory table where there are, in this case, 200 characters, and it'll just copy str over to there and return the address of the first character of this new block where you are allowed to use 200 characters contiguously. Does that make sense? Questions? Okay, so this brings up the question as well, potentially you might just not have that much memory anywhere contiguously or at all. Yes.
So does realloc, in that example, does it assign 200
potentially. So realloc will return the address of the new block, which has the same contents as str. So possibly there was just space after the 100 bytes of str already, and it'll just return the same value.
So is the block 200 or 300 characters long?
Right. So it might be that you could extend it and it doesn't need to do anything. It's just record, okay, now you have, like, starting with the current str, you have 200 spaces in the memory table. It's fine. Or it could say, it's not fine. I need to copy str over to some other location, and it'll return the address of the other location. And it'll do it automatically for you. Make sense?
So it depends on where STR is.
Yeah, well, it depends on where STR is and depends if there is stuff after the 100 bytes that it currently occupies. So if there is no occupied stuff after that, it'll just say, okay, I'm just returning the old one. Yeah.
Can you reallocate or make it smaller if you need?
Yeah.
And then will it automatically free?
Yeah. 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 Well, so like whether it will actually free or not is a little bit up to the operating system. So it might be that it seems like it freed it, but not actually. But kind of as far as what you can do and see, yes, like it could potentially free up some memory as well. Generally, people don't do it just because it takes time and usually it's not worth it. But, you know, sometimes. Okay, anyway. Sometimes it's going to be the case that malloc or realloc just cannot give you the amount of memory that you want, right? So here, if you count the zeros, so we're looking for 10 megabytes of, so a megabyte is 1,000,000 bytes. This is 10 million. So it's looking for 10 megabytes of space. Usually you would have that, but it's a substantial chunk. It might be that there's just no space in the memory table at all where there is contiguous 10 megabytes that you can use. And certainly on older systems or in smaller systems, completely could happen. So what happens in this case is malloc returns a special value, which is null, which is 0, but of a different type. But basically, we just say null. Null is defined in stdlib. So if you can use malloc, you can also use null. And yeah, if malloc returns null, that means that malloc failed to allocate for some reason, usually because there's just not an amount of space that you actually request, right? So what do you do in this case? Usually what you would say is, okay, like if it's null, I'm done. There's nothing I can do. I'll just exit. So exit, the function does that. It just exits the program. So the one is sent to the operating system. It's not necessarily used by the operating system, but that's like when you say return 0 in main, 0 means everything's fine. Anything that's not 0 could potentially communicate information to the operating system about why the program exited. All right. So the difference between exit and return is that return just returns the value from the function. Exit says terminate the program. Does that make sense? So it's not like a return. It's like, that's it. The program is done, regardless of like in which function you are. Make sense? So why exit? Well, the answer is like, what else are you going to do? Right? So you try to allocate the memory block. Presumably you're going to use it. And now you can't because there is no memory block. So, you know, there is like, you can't try to access it. That would cause the program to crash completely without an error message. Here, at least, we printed an error message before we exited. So, you know, that's the thing that you can do in our context. So if you're writing something with a user interface, like, you know, Word or whatever, of course, like that's not usually what happens, right? So what would usually happen is Word would display some kind of error message, but then you get an option to click OK and keep going. So the difference between what we are doing and, for example, Word is that Word has this loop where it asks the user for the input, and then it does whatever the user wants, and then it asks the user for input again, implicitly, right? So like any kind of mouse moving or like keystroke, that's input from the user for MS Word. We don't really do that. So we don't have this loop because the program that we write don't really necessarily interact with the user all that much. So for that reason, for us, usually like there's no option other than to just say exit if it didn't allocate. Word would probably just say, well, like, and in fact it does, right? So like you try to open a document that's like really huge, what's going to happen is it might say like not enough memory, could not do it. So the document doesn't open. but you get to keep going. You can create a new document, whatever. Right? So that brings up the question of, okay, like I haven't done error checking up to now, so should you do it? And the answer is, well, like if a user is going to be using the program, like obviously yes, because if you don't check for errors, it's not like the program won't crash. It's that you're deferring the crash until you try to access this block of memory, which doesn't actually exist. And then you would crash. You would not have an error message. You could potentially take down the entire operating system with you when you crash, which like sometimes happens, right? So in practice as well, like sometimes the like Chrome or whatever causes a crash and it takes down the entire thing, right? So yeah, so like obviously you should. At the same time, in class, the point often is to like demonstrate the language feature of the C programming language, or to do like a proof of concept for an algorithm. And then if all you ever do is like error check, make sure that it doesn't crash, that's just a distraction. So for that reason, in class as well, like in the lab, I would say, you know, I don't want to do error checking because it just clutters the screen. And I'm not actually writing stuff that I'm going to sell to users or whatever. Right? So that's kind of the difference. That's the reason that here I say sometimes, like the answer is like almost always I skip the error checking just because I don't want to clutter the code too much. So, you know, but obviously kind of if it's like real code that you're selling to the users or whatever, not even selling, obviously you should do it. Arguably, I'm selling to you the lecture contents, you paid for it, but it's a little bit different because I know from marking your exam that you don't all use the code. So that's the difference. Okay. So questions about that? So that's kind of malloc realloc. We'll use it later on today. But like mostly this is just like English, so it's fine. So I wanted to kind of do an aside and complete the conversation from the other day where we were talking about pointers and kind of matching types of pointers. I wanted to point out, so I don't know to what extent this was emphasized in Physics 180, but in physics, you are supposed to match the units, right? So for example, you know, like mass is kilograms and then acceleration is like meters per second. Did you write it like that, or meters per second squared? Right, which like I think is actually bad practice because like what's acceleration? It's like how much does the speed change every second? So it means like the speed is meters per second, and then every second the meters per second change. So I think it's like preferable to write it as meters per second, which is of course like equivalent to meters per second squared, but gives you a sense of what's going on. And force is of course newtons. So like, for example, like if the object falls with an acceleration rate of 9.8 meters per second, and it weighs 1 kilogram, then the force that the Earth probably is exerting on it is whatever, 9.8 times 1, and the units match, right? So newtons is kilograms times meters per second squared. If in the calculation the units don't match, probably something went wrong. So were you told this in Physics 180? Okay, so it's the same in C, right? So let's say that I want to make a function create string that allocates memory to a string. So let's say I want a string of length 100, and I want to like allocate space, and I want to say I don't want to do the error checking when I say create string. I want the error checking to be done inside create string. So it's like hidden. So for now, like if I want to use it like this, so I'm kind of designing create string right now. Well, it must be the case that I need to send the address of str to the function, because otherwise the function cannot change str, right? So if you want to change the value of str, which starts as a 0, it must be that you're sending the address. There's no other way. So what does it mean about the units? Well, str is of type char star. So if you want to send the address of str, the units, the type, must be char star star, because address of char star, str is of type char star, it must be char star star. That's just what address of does. Does that make sense? So that means that create str must look like this. It must take char star star str because the units must match. We're sending to it address of str because we want it to be able to modify str. So it must be char star star. And then what about star str here? Well, again, what does malloc return? Well, we cast what malloc returns to char star because that's how we create a block of chars. And then what's the so the type on the right-hand side is char star. So it must mean that the type on the left-hand side must also be char star. str is of type char star star. So to cancel out one of those, it must be that you have star str there. Is that making sense? Questions? So it's like a lot like str star. Maybe it's like an unfortunate thing because it sounds like a tongue twister a little bit. So let's do it in code. So str is of type char star is of type char star star. In fact, you might like to call it something other than str, maybe pstr. So here I chose to call it str. So let's in fact rename it to pstr. That's just the name, of course. And that's to distinguish it from str. All right. So str is of type char in main. And then pstr is address of str, and it's of type char star star. Right? So that means that, so address of str, which is equal to pstr, is of type char star star. Right? So that's because str is of type char star. So address of this, you add another star. Is that making sense? Yes.
Wouldn't it be, if the SDR is of type char star, then wouldn't it be better to name it PSDR and then the one that's of type char?
Well, I would argue. So the question to repeat is the answer is I think it's a little bit arguable, but basically I would say no. But so basically the question is like, why are we not naming the char star thing PSTR, and then we would name, I guess, the address of that maybe PPSTR or something. And I would say, well, if it were named something like my character, so car is taken, then yeah, like address of character would be P my character. But a string in C is actually a pointer, right? So a string in C is the address of the first character. So like to my mind, and like it could be that in different people's heads, this is arranged differently, and that's completely fine. But to my mind, so a character is like one character. You could have a pointer to a character, but an str is already a pointer. So that's what I would say. I think it's like, it doesn't matter how you think about it as long as you produce correct code. Yeah.
Just to be clear, for the input, for print string function, if you use a single cleaner, then the function you just lost your copy of the data, so you couldn't access that memory anymore.
Sorry, I don't really understand. So
If you use once, if you did use double pointer and only cost the symbol from that.
oh, that it wouldn't even compile.
Then
So the types must match. Right. So like if I try to pass just a car star to this, the compiler would say it doesn't make sense. So I could in principle say car star PSTR or something. I think that maybe is what you're asking, and then pass a pointer there. And then if you modify PSTR, then it only matters inside the function. So here, we're not modifying PSTR, we are modifying the value at address PSTR. So we're saying star PSTR.
okay, so basically if you had only had a single pointer, then that wouldn't change the value outside the function.
So I kind of don't necessarily encourage you to think about it this way, because remember, like if you want to modify an integer, then it would look like this. And that's a single point. Well, so I don't use this terminology. So like double pointer is banned in this class, actually, precisely because of this issue. That here, if you want to change an integer, that is how you would do it. But if you want to change a pointer to an integer, then you would do it like this. Right? That is not okay. So the point, so if there is kind of a heuristic here, the heuristic is that unless you are saying star something on the left-hand side, you are not really changing anything. And of course, square brackets are implicitly also star something, right? So to remind people. Right. So unless on the left-hand side, you're saying go to some address and change it, you're definitely not changing anything, right? So saying something like pint equals 0 over here has no effect. So the heuristic would be, so the initial question was like, if it's just one star, would it not have an effect? And the answer is like, in that example, yes. But there are constraints. So one, it has to be that the types on the left-hand side match the types on the right-hand side. So sometimes the question just doesn't make sense. But the heuristic is only if on the left-hand side you have a star, either implicitly or explicitly, you are accessing the memory table directly and modifying it. In which case this may, well, it will in fact have an effect outside the function. Maybe not the desired effect, but it will have an effect. Okay. If on the left-hand side you have a local variable, there is no way that it would have an effect outside the function, because line 13 is just changing the local variable pint. So if anything, that's the heuristic. Does that make sense to everyone? Okay. Questions? All right. So, okay. To continue with this function, so what are we doing here? We're saying I'm sending you the address of my pointer. So go to my pointer and change it so that the pointer now contains an address of a memory block. This is this line. And then we say, oh, like, did it actually not work out? So did we turn the pointer that we sent into a function to null because malloc could not find enough space? And if that's the case, inside the function, we'll just print an error message and then we quit the program, right? So the reason I'm doing and then like, okay, so we checked if this worked out, meaning that star PSTR is not null, then we go and we say this is going to start out as an empty string. So I'll just put a null in the very beginning, which means that if I try to print it, it's going to be nothing because there's a null right away. Right? So this kind of makes it convenient, right? So you can just say, you know, here's my str, just go and make sure that I can store a string of size 100 there and put a null in the beginning so that if I try to print it without modifying it, I won't get garbage, I'll just get nothing. Make sense? So that's kind of convenient. You could do it. So yeah, so I just wanted to complain a little bit about physics for 30 seconds. Sorry about that. So dimensional analysis in physics is kind of fake news, I would argue sometimes. So for example, you have, you know, like Coulomb's law there, like you might not have done it yet, but this is kind of whatever, like the force between charged particles, right? So this would like the charge of the one, the charge of the other divided by r squared. So it's kind of like the law of gravitation, which I'm sure you have done. And you'll note that the dimensional analysis here is completely fake as far as anyone knows, right? So the reason the units match is that Coulomb's constant and the gravitational constant have those completely fake units that make everything align. As far as anyone knows, it might be that once people come up with like a grand unified theory of everything, it would be explained why it happens that G is in the units newtons times meter square divided by kilogram square, and K is whatever, like Newton meter square divided by Coulomb square. Really weird, right? But like the reason dimensional analysis works is that those constants are just rigged so that it would work. There is no other reason for that. All right. Sorry, physics 180 people. It's just true. So okay. So back to talking to things I know about. Although I am completely correct. So don't tell people. Well, or do. It's actually all true. So str cat. So to remind you, so cat stands for concatenate. And what this does is it sticks str2 to the end of str1. It doesn't check if there is space. So if there is no space at the end of str1, it would just crash the program. And like why? Well, again, like C prioritizes efficiency. It doesn't do error checking for you. You might imagine that it might make sense that malloc rather than you would just, you know, print an error message if you return a null. It doesn't do it. Now, it makes sense in the case of malloc because, like, well, maybe you do have this loop that Microsoft Word has, and, you know, like, if you ask for too much space and it says, no, you can't have that, you can say, okay, well, I'll try other things, it's fine. In small programs, it makes a lot of sense. So kind of the malloc things make sense. The fact that there's no create string and you can make it manually if you want is kind of this philosophy of C that prioritizes efficiency and lets you shoot yourself in the foot or shoot your user in the foot, hopefully just in the foot, if you are so inclined. Okay. So what I want to do, and I think we'll have to complete this on Monday, is do something with strings that's like more Python-y, right? So make it so that there isn't this issue where strcat might just crash, right? So let's take a first stab at it. So I'll name it safe str, well, safer str cat. So what do we need here? So first of all, I cannot just send, this is not safer, this is just str cat. So I cannot just send it the string, because if it happens that the string str1 just doesn't have enough space at the end of it, there's absolutely nothing strcat can do about it, because all it cannot change str1, it can only change the content at str1, and if there's no space at the end, nothing you can do. So we'll send it pstr1. And we'll send it str2. Okay, that what Copilot was suggesting there is a memory leak, so we won't do that. Okay. So first of all, we want to see, okay, so need enough space at star pstr1 to hold both str1 and str2. Right? So, okay, so how much do we need? So we need as much space as str1 has, and then as much space as str2 has, and then one more byte for the null. Does that make sense? So, like, this is not intuitive and it's hard, and the only thing I can say is do the pointer exercises. You'll eventually get used to it. So I realize that right now I'm kind of probably pushing it, and you're probably tired from the praxis deadline. But at the same time, we kind of have done the elementary stuff. I can, like, just like, like if you're training for a sports thing, I can tell you what to do. I cannot do it for you. So what I'm doing now is I'm showing you kind of where we're going, and I'm trying to talk you through it, but kind of having it talked through for you is not the same as being able to reproduce it. So what I suggest is kind of the pointer exercises, which are kind of short. It's not going to take a lot of time, I think. Or if it does, then it's good and you should take the time. And then you can move on to the applications as well. Project 1 is also going to involve this kind of stuff. Right now, like, I recognize that probably like this, for example, is not super intuitive. So again, why is it star pstr1? Well, we're sending the address of str1 to the function. And that means that if we want the length of str1, we need to go to that address. At that address, there is an address of a character, and go to that address. So 2 jumps. And then we can like go through the string and find where the null is. Is that making sense? Questions? Yeah.
So I assume that plus 1 byte is for the null.
That's right.
But why is it just 1 byte instead of 2? Because there are 2 characters in null.
Yes. Well, they used to be 2, but we're sticking str2 at the end of str1. So we are overwriting the null that used to be at the end of str1. Right? So the picture is kind of like, so let's say that str1 is like E and G. And then there is a null. And then somewhere else there is a psi. So the question was like, why +1 and not +2? And the answer is what we're doing is we're taking this and we're sticking it at the end of E and G. So the end result would be we are overwriting the null that used to be here with a capital S. And then at the end, we just need the 1 null. Oh, that's just a symbolic representation. So anything in single quotes is one character. It's just that this is like the literal 0 digit, and this is the null. Right? So in the same way that like new line is a single thing, it just represented as \n, \0 is the null. It's not actually the 0 digit, which is a separate thing.
That makes sense. Thank you.
All right? Yeah.
If you're overriding that counter, don't you need one len by
So strlen doesn't count the null. strlen tells you how many characters before the null. Yes. Yeah. So the reason is we need the pointer for str1 for the same reason that we needed the pointer when we said create string, because it might be that we need to relocate str1 because there is not enough space where it is current. For str2, we don't need it. And you might argue that like for symmetry, even though you don't need to modify str2, just for symmetry, make it a pointer to a pointer as well. Or you might say, well, if you don't need to be able to modify str2, it's better not to enable the function to do it accidentally. So just don't give it the information that it doesn't need to know. Say it. So you could. Yeah, like so you could even say so. You could say it's const car, and then yeah, like that's like another safety. In fact, let's keep it. So that's like, I wasn't gonna modify str2 anyway, but just to make sure that the compiler doesn't allow me to, yes, I can say const car. Right, and in fact, like if I'm really worried, I can like also do the const over here. So yeah. But like to be honest, like I think this is like again like adding clutter that's like maybe at this point too much, so I'm not gonna do it. But technically, yeah, like you can say I definitely don't want to modify str2. I don't want to do it accidentally. I'll just make it a const so that the compiler would yell at me if I try to. So okay, that's like that. So now we just need to find some space for str2. So we can just say realloc. Like so, right? So this is just this. So realloc, like it sounds like reallocate. In fact, if it sees that there is enough space, it's just gonna return the same value again. So star pstr1, which is str1, is just not gonna change if it doesn't need to. If it does need to, because there is not enough space, then it will. And what we're doing is we're making sure that str1, so the way we would call it is address of str1, str2. So modifying the value at address pstr is modifying str1. Does that make sense? Questions? Yeah.
Can you recast the realloc too?
Yes. So otherwise that would be a warning. So that is a car stop. Thank you. All right, makes sense. So now it might be that there was enough space. It might be that there's just, there's space to store str1 and space to store str2, but there's no contiguous space that could hold both if they're really long. So we'll check if star pstr1 turned out to be null. And we'll print an error message and we will bail. Make sense? So again, why is it star str1? Well, one way to think about it is this is str1. So anytime I mean str1 outside the function, I say star str1. So if I set star str1 here, well, if I want to check the value that just got assigned, well, I just said the value is star str1. So it must be that I again need to use star str1, right? So I'm just asking, did the left-hand side turn out to be null? The left-hand side on line 24 is star str1. It must be, right? So here you don't even need to think about the meaning. It's, you know, I just got the return value from realloc. I want to know if it's null. The return value got stored in star str1, so I need to check star str1. Yes.
If str1 is not different in the now, can we still do realloc here?
No. So that's yeah. It must have been allocated with malloc, and that's a good point. There is no way to check. Okay. Yeah, it could just crash, and there's nothing to do. You can, well, in C, like in principle, you could try to like inspect the memory. A modern operating system is not going to allow you to do that because, well, like in this case, you might have good intentions in terms of I just want to check if it was like allocated with malloc. So could I look around? You could ask the operating system. But a malicious actor could say, I'm just looking around to make sure my program is safe. And in fact, it's stealing the password from your browser or something, which is also somewhere in memory. So for that reason, a modern operating system is not going to really let you snoop around like that. Does that make sense? So, okay. So that's like that. So now that we are done, we can call good old strcat to stick str2 at the end of str1. str1 is aka star pstr. Oh, great. My computer is frozen. But we are done. Questions about this? Yeah.
We call simple STRFN, right?
Say again?
We call simple STRFN.
Yes.
Like outside this.
That's right.
Sorry.
Well, I mean, you could now that you've written it.
Oh, yeah.
Right. Yes. Sorry. Quiet down, everyone, please. I can't hear the question. So here, like you're right that I usually do. So size of car is always 1. So technically I don't need to. Everything else you can't assume the size of, but car is actually always 1. So that's kind of fun. There was a question somewhere there. Yeah. So that's because I might like to relocate str1 somewhere where there would be space to stick str2 at the end of it. And it might be that there is already space, but it might be that there is not.
Right, and because reallocation isn't allowed, we just directly do.
I mean, you could, so it's not that reallocation isn't allowed, it's that you cannot modify str1 outside the function unless the function knows the address of str1.
Right. Then
and we sent the address of str1 to
right, because any change you make to it would
yeah.
be useful.
I mean, you could say it like that. I prefer not to think about it this way. So I prefer to think about it as I have this variable outside the function and I might like to modify this variable.
Right.
How would I do it if I don't have the address of the variable? I can't.
Got it. Thank you very much.
Okay. All right. So there was some announcement that people wanted to make. Do you want to come to the front and do that?
Okay. Just quick announcement. We have class picture right after this class, 12:20 to 12:40 in front of Con Hall. Just make sure you guys are there. If you guys don't know where it is, just follow us, okay? That's all I have.
Also, for the people watching online, if you can't make it to Con Hall by 12:20, the photo will be taken with or without you. So if you show up late and there's no space for you, it's on you, not on us.
I'm not sure it's being broadcast, but also nobody watches this, I think, approximately. So, or like people watch after. No, people watch after, but they don't do live. Yeah.
Thank you, Professor.
Anyway, yeah.
Thanks, guys.
Try to multiply a float and a double. Will it do funny stuff?
So that just gets converted into double. So in the same way that like if you multiply an int by a float, that's just a float. Double times float is just a double. So that it just converts to the kind of most general
That
kind.
could work, right?
Yeah.
It's 1 second.
Yeah, like that just has to double. Yeah.
Yeah.